This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg. My guest today is Daniele Gamba. He's adjunct professor of machine learning and CEO at AISent. He already suggested he's very interested to hear how I pronounce the name of his company, and he can comment on that in just a couple of seconds. Our topic today is going to be AI algorithms for industrial applications. Hello, Daniele.
Hi, Peter. Hi. It's a pleasure to be here.
What did you think of my pronunciation of your company name?
Yes, as I was telling you before, every customer of ours pronounce our name differently. So we have this joke inside that it's a miracle that someone's actually find us on Google. So
okay,
don't worry about
that. Anyway, we'll do that later on as well. But AISent, AISENT. Yeah, so, Daniele, please introduce yourself to our listeners and let us know what you do at. Tell us a bit about your company, AISent.
Yes. So, I'm the CEO of AISent, and I'm also adjunct professor of machine learning at the University of Bergamo in Italy. I mostly work with AI to solve industrial problems. So, my company was born 5 years ago. We are no longer a startup in Italy. We are just an SME. And we try to provide our customers with solutions that are heavily based on AI algorithms. So we have this experience since we were researchers in the university. The founder team was all researchers and professors and PhDs. And we were doing applied research for industrial use cases using AI, and with two different topics, main topics for us. One is computer vision, with all the processing of images, videos, 2D, 3D sensors. And the other part of the team is related to time series and mathematical modeling. So these are the two main topics we work on. And we work providing our customer with the final solution, the complete solution, whether this is an industrial machinery or just the algorithm, but with the aim to, let's say, create more autonomous industries. So we see in a lot of customers, in a lot of industries, a lot of work done by the people that is heavily automatizable. I don't know if it's the correct term.
I understand what you mean, yeah, right? Mm-hmm.
Yes, there are many tasks that are inhuman, and we want people just to focus on the more human tasks and not doing the robot job. Also, here in Italy, we feel very much lack of new operators, lack of personnel in the industries, and lack of expertise also. It's a very, very important topic for us. So we try to build this kind of solution that could be computer vision, could be mathematical modeling, that allows the current operators of the industries to perform tasks that are more human-like, human-friendly, and not robotic tasks.
Okay, sounds great. I'm sure we'll be discussing both the computer vision side as well, the modeling. You know, a lot is happening in modeling, applied research in the Bergamo area. I want to come back to that later on as well, as you live south of the Alps, I live just north of the Alps, but we'll do that later. And before we get into more details of AI algorithms in the industrial area, maybe you want to share with our listeners the, let's say, the bandwidth of your AI-type markets, sectors, and solutions, which I believe is wider than just industrial, right?
Yeah, correct. We mostly focus on three segments. One in defense, where we have Leonardo as a customer, the main Italian defense company. We have a few customers in transportations, and most of the customer in manufacturing, industrial industries, both with OEMs, machine builders, and the final customer, final users.
Okay, so I understand that as you're not a startup anymore, but as a starter use case maybe. So you concentrate, you do a lot in production quality improvement. Maybe you want to share with us a use case or two, what, where, how, what the result has been, because that's of course always, I believe it's the entry use case for most listeners, right?
Yes, we have a lot of use cases in industrial quality control because most of the time it is a human job to like perform quality checks on, let's say, plastic packaging. And this kind of application resulting in a build of a machinery with the industrial cameras, illuminators, etc., etc. And obviously, the main part is the AI algorithms that interprets and understand the products and understand what is considered a defect, a fault, or not. This application, obviously, we built a lot of machinery for these different sectors, like in heat sealing, plastic packaging, polyurethane panels, luxury items, vials in pharmaceutical application. So a lot of application, but at the core, we always see the struggle of our customers in using technologies that are more related to the human interpretation of what you're seeing and less like mechanical specification. Okay, we have this kind of defects, is it visible, etc. And in these cases, let's say in plastic packaging, for example, or in food inspection, most of the time we implement the machine, we make it run in production in our customer plant, and we start collecting data. And these data are not used continuously, I would say. Something very peculiar I've seen many times, but sometimes it allows our customer to address the root cause of the implementing defects, that is producing defects. This is the main. Sometimes it's hard to measure the quality improvement that the vigilance system and the quality inspection system allows it to do because it's so sharp, the changes where we can collect data and tells back our customer, okay, I think this could be the problem, or this is the data we collect from you. And sometimes there is the epiphany and this realization in our customers that says, oh, okay, is that problem? Is that, I know where to put, I know where to fix the process.
Sometimes it's easy to fix, but sometimes it's way too difficult engineering. And then maybe they wait until the next generation and you put in there your model to make sure that it doesn't happen again, or?
Yes, in quality inspection, we mostly discard the products and collect the data about what was the fault that resulted in the discard. Also in steel production, we have a lot of application in inspecting steel products that can be solved. The defects can be solved on the process. And sometimes it requires more just a moment of understanding of your process and it's not a process that you have to do continuously. It's sometimes just stopping your activity, stopping the quality laboratory and just okay, we have this data. Let's look into the process to understand what is the root cause that is producing so many defects.
Right. So you mentioned a couple of times now that you're involved in packaging. So is it where you're based, Bergamo? Is that part or close to the wider area of, I think, what is being called the packaging valley? Is that right?
Yes, it's 100 kilometers, I think, 100 or 200 kilometers. The packaging valley it's a lot of OEMs, producers of machinery. We work a lot with their finals. We work a lot with the final customer that implementing inspection of the products coming out from the machine.
Yeah, but again, as I suggested before, I mean, it's been some time, but as I, living north of the Alps, would drive over the Alps and arrive into the Po Delta, right, and I would recall that as I was more kind of involved in industrial pure applications, that I would be driving into the packaging valley kind of thing, right?
Yeah.
The second application that you did not mention here, that's another one where maybe one or the other person can relate to is you do predictive maintenance on marble cutting machines. And there's this beautiful picture. And those of you listeners who may have been, for business reasons or maybe for, private holiday reasons in the same area, I believe, but you want to correct that, if not, Daniele. You may have visited one of these, marble cutting areas where, you cut big pieces of marble out of the,
Of the mountain,
out of the mountains, exactly. Right?
Of the cave, yes.
So what do you do there then? How can industrial algorithms help to improve the marble cutting?
Yes, in marble cutting, but in many cases, OEMs struggle to do predictive maintenance, and we built quite a few algorithms and published quite a lot of publications of articles on journals about predictive maintenance. Because sometimes, or most of the times, collecting data is a real struggle, obviously. Because to predict how many hours you've left on that component, you should have seen at least a couple of components degrading their performance during time, And this event, collecting this data, is very expensive, is in time of effort of our customer. So in Marble, but also with the CNC, let's say, control numeric works and big OEMs, we worked a lot to create synthetic data of the degradation of performance of their components. So we can generate a lot of data, a lot of tracks that enables the algorithms to learn, to predict how much time is left for that component.
Tell us a bit more about that, because we've heard that many times before, and I always question, but maybe I heard the reason for it already. Synthetic data means that you simulate the cutting, in this case, the marble cutting situation in the lab, I don't know, at the customer side or with you. And then instead of needing to go into the marble cutting side and taking the real data, but here I'll stop. So tell us a little bit about the use of synthetic data. Yeah.
Yes, it is correct. We collect a lot of data of same machines, of new machines that, let's say, in FAT tests before shipping to the customer. We know they're good, they work perfectly fine, and we can collect easily a lot of data in testing, in cycles. And then we study the behavior of degrading components, and we study it from a physical aspect, obviously, but also from, let's say, few samples that we can collect from the field, from actual working machine. And once we have these two information, our team of data scientists can design an easier algorithm, let's say, that emulates the same degradation, the same signals, maybe on the torque of the motor, maybe on vibrations, and try to use these simpler algorithms to emulate and to simulate the degradation of performance. With these two information, so same tracks, same samples from the new machine and this simulation of degradation, we can generate quite a lot of data that can be used by an algorithm, a predictive maintenance algorithm, to estimate the remaining time.
But in the end, it is synthetic, right? It's not the real thing.
Correct.
Like what I'm thinking of now. So if you would have to go, and maybe you can sometimes, but not often, go into, let's stick to the marble cutting. I mean, it's a very dangerous kind of environment. I guess there's explosions, I believe, every now and then to get the marble out and stuff like that. So many of those real life values, let's say, you don't get, but still. So you do the simulation, the synthetic data in the lab, so to say, and then at least you have a starting point for applying them into the field.
Yes. And an application with a big OEM, it resulted quite a lot accurate. Also, the synthetic data was very, very well performing. And in 6 months, we completely built like 10 different algorithms for 10 different problems that in this case, the CNC machine was having, and performing like predictive maintenance on 10 different components in just 6 months of project. One relying on synthetic data and obviously the same data that customer was letting us to do.
Yeah, it's a growing in a big market, and here you are just sharing with us another a great example. I realized, I think I was asked, was it 2 or 3 years ago? I think there was a company who wanted to invest in another company. They were asking me about what I thought about synthetic data, and I didn't really have a view on it, I must say. And I've learned in the meantime a couple, and the big example being, if we talk about autonomous driving, the child running in front of a car, you don't want to test that in real life. It's so of course you're gonna try to do something synthetic. And today you give us another great example. Now, you talked a couple of times about the algorithms. Now, before we get into the algorithms, I first want to know from you how you sell your algorithmic products. So do you sell actually algorithms? Do you sell a complete package with consulting? Do you have an embedded solution? Maybe you want to first talk about that. What is your offering to your potential customers?
Yes, we do sell a complete package that is including consulting and developing the project. Since we have a lot of experience with different sectors, it's easier for us to, let's say, benefit from different application of the algorithms in new challenges. And so we do sell our experience both in the code of the algorithms and the consulting. And this is most for this kind of application for predictive maintenance. In the vision systems, we do provide also the machinery itself. So we do provide the complete robot, the cameras, all the automation. We try to build, we are a machine builder of our own for quality inspection application. So yes, it's different for different markets.
Okay, so it's not or never maybe just an algorithm. There's a job, there's a request, and 1 month later you send him an algorithm, a piece of software, and you say this costs XYZ. That's not the way it happens, right? But at the same time, it's also maybe, and we come to your Chandra, I think, so you do sell solutions that are a combination of hardware, software. So in that case, maybe they are kind of off the shelf. What I'm getting at is like, when we started this, let's say, industrial AI data stuff, I myself, 5, 6, 7 years ago, there was nothing it was completely new. And now it's still, depending on the market in which we're in, it's still more or less new, or other markets are already used to it. And you could never do anything without the consulting. So that's what I'm getting at. So are there sections, pieces of your sector's markets where you say, no, we have a solution that is already off the shelf that they can buy as such? Maybe your Chandra is one. And in other cases, we still need to do the consulting because the markets, the people in the markets have yet not an understanding of what this is all about.
Yes, it is clearly correct, the way we proceed. Also, Chandra is our full stack application for quality inspection and enable our customers to train their own algorithms for quality inspection and to provide it on quality machines. And I just closed a very big sale with a customer, with a competitor, let's say, that producing himself quality inspection machineries that will adopt Chandra as its core, because he understood the quality of the work we did in these years.
Okay. Nevertheless, then let's maybe, you shouldn't go too detailed because that's not what we're about here in the industry. No, but nevertheless, if our headline today theme is about, AI algorithms, talk a little bit about the algorithms, like on a top level, are they supervised, unsupervised? Is there one or two where you say, I need to mention that name because that is always the winning one? Or what can you say at a relatively high level about the algorithms, how you developed them, what they are they based, are they open source, are they your own ownership, etc.?
Yeah. One thing it's important to mention is that synthetic data is quite a lot important, not only in time series, not only in modeling and predictive maintenance, but also in images. And you were telling about the child running in front of the car. We do the same with the faults on quality inspection, on robot guidance. We generate quite a lot of synthetic data. And the synthetic data enables us to pre-train most of our algorithms, both let's say, anomaly detection. So unsupervised learning in understanding what's wrong, what's anomalous with the objects we're looking at, but also supervised synthetic defects. So injecting fake faults into the images, into the collected sensors, and trying and having that it's already labeled, because we inject the fault and we already know, and the algorithm already knows where is the defect. So it's very useful and very challenging for us also, because we have to, let's say, write every time few libraries that enables us to recreate that fault that can be very strange. In plastic packaging, we had a lot of thickness problems due to recycled materials. And we try to recreate these thickness anomalies into the images we collect from the sensor. So this is a crucial point, because it enables us to, let's say, take 10, 100, 20, 30 pictures of same products and then generate 10,000 images with different applied synthetic defects. And this is a very, very important one for training then obviously both the anomaly detection algorithms and the supervised object detection, object segmentation algorithms. We do develop algorithms of our own. We obviously started from the most notorious papers, but the research part is quite important in AISent. And we do a lot of edge computing for NVIDIA boards.
Right. So I wasn't going to talk about cloud or edge. It's just because Robert, my colleague, has been telling me that I've kept on talking about the edge for 3 or 4 years right now. But do share with us then the Italian market. I mean, why are you, if I understand, concentrating, maybe not exclusively, but what is how big is the share, let's say, of your total revenue of edge solutions and cloud solutions? And tell us a little bit about why your customers, then choose or are interested in the edge solution.
Yes, right now it's about 80% on edge and 20% in cloud. The cloud part will grow with a new project we will launch this year, but most of the time we have to be very reliable in our prediction. In industrial AI, we have to be very robust, very reliable, close to real time. Obviously not perfectly real time, but close to real time. So having a reliable edge hardware enables us to forget about the internet connection, forget about everything else, and just be sure that the edge device will perform its job autonomously.
Okay, sounds great. I recall, I haven't talked about it for quite some time, but as you remind me now, I think it was like a year ago when the European Union, and you may recall, is it one of the top, in this guys, there's a number of women, this the second or third in command, European Commission, and he is the former CEO of a French IT company. I'm just saying it like this, maybe you know him. And he was exactly giving out the directive to change in general, not just the AI solutions based on cloud, which he said at that time was 80-20 edge, and he wanted that exactly, at least for the European market, to change towards 20-80 or 80-20. And now you seem ready to be at exactly the solution where he wanted us to go. And I was a big supporter of that. Now, we are a global podcast here, so we leave in the end, the decision to go with edge and there's another topic which I would like you then to comment on, but let's stay with this first, is like, if the customers prefer for whatever reason cloud, they should do that. And if they prefer to go edge, they should do that. And we are agnostic here. So, but as you were saying, because we like to talk about industrial grade, it's a term that Boris Scharnger from Siemens kind of, I believe, has come up with. And most certainly a part of this industrial grade is, as you say, needs to be close to being real time. Maybe you can talk about that a little bit more. Is that what customers come to you with as a request?
Yes, I think it's one of the main topics to be not only real time, but also to be very reliable and to perform always within the same way. And if something changes, we do expect the algorithms to or adapt or to perform slightly worse, but not completely worse. And building industrial application means that we have to build very robust algorithms, very reliable ones. And they have to be not only reliable, but also explainable. It's a trending topic in EU discussion, obviously, and also ChatGPT, very trending one.
Oh, we come to that later.
And obviously, we have to prove, and we will have to prove, but right now, some customer already asks us to prove the robustness of their model.
Yeah. Well, you're bringing me to the next topic, so I think you were going to discuss it anyway, because you and your colleagues, I believe, will come to that later in the end to your team, but you are former researchers from the University of Bergamo. You're still yourself an adjunct professor of machine learning, I understand, and you and your colleagues have published a number of papers, and one of them is machine learning models robustness. The other one, we'll come to that in a moment. So tell us a little bit more. You were in the stream anyway. So what is in there? What is about machine learning models robustness, I guess also specifically for industrial grade applications?
Yes, this was a research we did for a customer in blood treatment. And obviously, since we were handling blood, there was a lot of, certification and tests we had to provide to certify that the algorithm was telling us the correct answers, the correct prediction. Okay. And it was a supervised and regression problem. We were trying to understand a few parameters of the blood coming from the sensor of the machine. So we researched a lot what was the meaning of robustness. And we arrived to this conclusion that is the ability to perform well enough even if the environment changes. So even if there are few components that changes, there are few signals that changes, the algorithm has to, let's say, be wrong less, okay? While on, let's say, overfitted algorithms, it's very easy to see that if something changes even a little bit, the algorithms is completely wrong in its prediction. So we developed and we designed this robustness matrix that is just two integrals, nothing crazy, but in the paper you can find on Google Scholar, I think it's open access. You can see there is just this formula that tries to bring and formalize the concept of robustness, and we implemented that in a TensorFlow callback. So when we do train algorithms and with a TensorFlow, for example, we have obviously the accuracy, the metrics of our model, but we also have the robustness metrics. And this allows my data scientists to understand if the model they're training, it will be robust enough to provide consistent prediction in time.
Right. Sounds a lot like the safety robustness that we talked about, I believe, with Airbus in the same area, getting an even higher level. And what is interesting here is I think you talked about the use case was actually blood, so medicine. Although we like to think of if I say we concentrate on industrial grade as a very high level grade. And of course, implicitly, at least doctors, people in the medical market, they have their thought about what is
medical grade. Yes, correct.
Careful with that, of course, and of course, the leading, maybe again, I've mentioned them before, but the leading drivers will be the European Commission in the end with the AI Act, and they're going to tell us, which are the risk. Is that one? No, it's not the only one, but of course. And if they're going to say, this is the way of finding out what is a highly risky AI application, that's then another, let's say XY grade level of, there's going to be so many, maybe that's only a little. And that is the discussion where many people are afraid on one hand that they're not allowed to do the things that they want to do with the AI. And maybe that's good or bad. We're not going to talk about that today. There's a second one, and that's also, you refer to it in the direction of explainable. Not sure you meant the same, but you did a paper on causal inference modeling, which we've talked about half a year ago as well. And it seems to be in the meantime also like a huge, trendy, so to say, but good, important topic.
Yeah, it's causal inference. It's a very, very interesting, very, very trending topic because it's explainable in its definition. You explicit all the variables, you explicit all the relationship within the data, and then you can try to build a model that estimates a treatment or that predicts some value, but is I think it's the most explainable AI we can try to have right now with the techniques we have. And we worked a lot on causal inference and Bayesian modeling, and we developed an algorithm that we believe reason like we do. It's something that obviously in industrial application, obviously in very specific tasks, like in troubleshooting or in training new operators. But we aimed, it's a year and a half project, we aim to build this algorithm that reason in troubleshooting like we do. So it will observe a few things, it will try to estimate these causes, and then it goes back to observe other indicators that could indicate, that could point towards a cause. And this is a very big project of ours because it enables our customers to digitalize the expertise of the most experienced operator. And some OEMs is already trying to build new business models where they sell the knowledge they have inside the company to their customers. So they try to digitalize their expertise that is inside of the people, that is a very important part of the company, and to build a digital service that can be sold as a service to their customer, and interacting with a more interesting service, more customer service, let's say, a more reasoning one. Okay.
Well, I was going to be moving into the next topic, generative chat, etc., and I was going to ask you exactly that, because in the past, typically until now, today, it's the human expert, it's a domain expert who, in the end, has to confirm that whatever correlation, let's say at that level, a correlation first between what an algorithm has found, 1, 2, 3, 4, 5 correlations. I've given this example a couple of times over the last couple of years, but I think it still applies. And then the human expert, the best, as you say, human expert, will confirm, number one, no, that's no correlation, and certainly no causal relation. Number two, number three, yes. Oh, wow, interesting. That seems to be causal. And then the next question is going to be, and then we move into generative chat GPT and the stuff like that. Is this a one-time opportunity we have in these years, so to say? As long as we have those experts, you were also saying like a lack of experts, lack of workforce, maybe. It's more philosophical questions. Can algorithms in the future decide for themselves if, other algorithms, causal algorithms have found the correct causal relationships or not? Or can that only be done by humans?
This is an interesting question. It's a very, very broad one. So, okay, let's start from generative. It is a one-time opportunity, correct, to digitalize the experience of the most trained ones. And when they will retire, there will be a lot of lost knowledge that the companies will have to face. And I've seen it in a couple of customers. And when they lose their most trained ones because they retire, it is a challenge for the company to grow back that kind of knowledge. And we think that with the Bayesian modeling, with our solution, it's easier to digitalize this experience and to design what the knowledge is about. And then we can leverage the power of the generative models like ChatGPT, I really share this opinion from Pablo Solman. It's a well-known hacker, that his idea, ChatGPT, is not a revolution per se, because it's, let's say, chatbots and generative models also for text exist from quite a few years. But it's a revolution in design. It's a revolution in user interfaces, So we have this new powerful technology, this new powerful user interface that is text, that reached a level that is usable now, let's say, and it's quite powerful, but it has to be alimented from deep knowledge. And creating and digitalizing that knowledge is a challenge we have to address now before it's too late. And then we can easily take these new technologies, these new chatbots, and give them this knowledge that we have digitalized, or just adding them to interact with let's say, a causal model. If we are to let them decide autonomously, I think in a few cases it could be good. In most of the cases, it's maybe.
Yeah, I would hope that at least for the next 10, 20 years, as long as I'm going to be part of this, that humans are going to be using it as a tool. So in the end, it's always going to be the human. Say, oh, no, thank you very much, algorithm, not at an algorithm level. Thank you very much, ChatGPT, for this wonderful proposal, but I'm not going to use it, or I think it's wrong, or it doesn't matter. We know that the answering questions side is many times wrong, right?
Yes, most of the time, I think that these tools will interface with people that will have a lower knowledge. Let's say it's younger operators that has to be trained, and then you will have this powerful tool to train, to do troubleshooting, even if you have just a few years of experience. It's different from the most experienced one that will always have a deeper understanding of the problem, so they can also be very critic about the prediction of the algorithm. But for most of the let's say, younger operators, most of the younger workers, it will provide, I think, a very good support for like 90% of the cases.
So it certainly feels like a revolution as far as I'm concerned. I mean, I look outside a window, the world is still standing. It's raining here today. Shouldn't have been. Well, although we say April does what it wants to. That's a very bad direct translation. Sometimes it's sunny here, sometimes it's rainy. I'm sure where you are it's sunny, don't tell me. But, or agreeing with me, nevertheless, Italy has banned the use of ChatGPT. I just thought about, what do you, as a person as an Italian living in Italy, what do you think about that?
Yes, we have the authority about personal data protection that not clearly banned, because ChatGPT stopped the service in Italy after this authority request. And the concern was right, since there is a regulation about how you interact with personal data. So it was like illegal in Italy, and that kind of service in that way, in the way they implemented ChatGPT. But at some point, I really don't understand a lot of the discussion about this, because the APIs, all the services are still on. You can easily access them. It's just the web interface. So,
I was thinking, I'm not sure how you can ban something like that. I mean, we've heard about China, and I say that always very objectively. There is never a value related to it, but we hear about how maybe the Chinese government wants to block certain things, and then maybe they do that or then the Chinese users maybe, and also here, you're very welcome, Chinese users, listeners, get it anyway through a VPN. So that was one thing I was thinking, how can you block these days access to web applications?
No, you cannot. You cannot
Okay,
block
good.
this kind of service, and you cannot block this kind of release.
Okay.
But I think the companies, the industries, has to stop and think about for a moment how we do implement this service inside our processes, because it's a huge fact and it's really important to understand when and where and how we can leverage the powerful ChatGPT and one of the main GPT's models inside our processes to do our work right now faster and better, but clearly knowing that the data we share also in Italy could be sensitive data. And Samsung, I think, did a very important data leakage, had some trouble with it, with some operators, some employee inputting into ChatGPT sensitive information, industrial protection.
It's a hiccup, I guess, but it will not happen in the future, because I'm a big believer of, companies, and that was somebody else again suggesting yesterday, there's 1,000 new proposals every day, right? I don't understand how you can find half an hour to chat with me. And then I am a strong believer of what that person on LinkedIn, I think, was saying, is to say, sure, in the future, we're not going to have normal websites. We're going to have just an interface, and very important, so many things that come together. Sam Altman, right, OpenAI boss, he was part of a group of people from OpenAI talking to the Italian regulators. Just that's on the side. And he, in another interview YouTube with Lex Fridman, was saying that he also thought 10, 20, 100 years further, if we were going to look back and this was a time where we say there was something big happening, which was it, he would agree with what you just said, a ChatGPT, so the user interface, that was the big change. So many things happening. And if companies are going to have a ChatGPT kind of user interface on top of their own data, whatever the data is, then you don't need websites anymore. And then, of course, coming back to the Samsung, it's very important that whatever you feed in, is not going to be brought back to the general public open space, especially not if you're something and designing chips, for example.
Yeah, correct.
So, Daniele, we need to come to a close. Tell us a little bit about your team. Who are you working with? What do each of you do in the wonderful city of Bergamo in Italy?
Yeah, we are 20 people, close to 20 people now. And we have quite an important presence of PhDs, because the research part is still in our DNA. So we have like a third of the employees have at least a PhD. The other part is mostly related on data scientists, machine learning engineers, and computer vision engineers. So a few of the founders are still in the academy world, still in the university as researchers, also as professors. Me myself as a adjunct professor, so just a contract for a couple of years. But we really work closely to the research world, not just the University of Bergamo, but with other universities, also abroad, to be very active and in research and trying to experiment in the industries what the research provides.
So, as I assume all of you are well connected in the Italian, market sectors we talked about now, with an interest specifically, of course, in industrial, but also as many of you are PhDs and researchers globally, where then are we standing as far as, what we talked about, AI algorithms, soon to be moving into generative ChatGPT? Where are we standing? Where are we standing, you in Italy, in Europe, in relation to United States, China, Asia, and how do you see this position, this status in which we're in today? How do you see that changing over the next, a couple of years?
It's a challenging question. Obviously, I think it's an evolving market. So where competence and having a few years experience in applying AI in industrial cases is very important to understand the changes we're facing Otherwise, it's easy to fall into the new mood, new trending topics and losing the bigger and broader perspective on AI and on the real business use cases we have to obviously solve and to provide value clearly to our customers. So having this challenging market that is continuously evolving requires us to be attached to research. And the researchers, obviously, in the United States, in Europe, I've seen a lot of beautiful publication in AI, both in France, for example, in Italy, in Germany. So I think Europe is having a more European approach to AI, more, let's say, stable and reasoned approach, while other countries in the world are more running towards creating something that is more and more powerful. And this will change a lot, and we are sure that there will be a lot of changes, and having this dream to let the people do the same more human work and leave more inhuman work to robots and to algorithms is something that allows our companies to be more productive and to be more local, probably within its production, because most of the time-consuming and expensive tasks in Eastern markets could be automated in some way, and something that I think is quite important.
And allow humans to feel more human-like, whatever that is.
Yes.
Yes. Enjoy the wonderful Italian life, for example. This morning I had a song. I'm not going to sing it loud, but it's like, mare, mare, mare. Okay. Peter. And that's the song about, maybe you know who it's from.
Maybe
It's about the Italian at the sea, right?
Yes, correct.
Beach in Italy. Daniele, thank you very much.
Thank you.
Thank you for you giving us this this Italian perspective on AI, on generative, on causal, on robustness. Really great to hear. Great to hear what you're doing. If you listeners want to get in touch with Daniele, can you do that by LinkedIn best or?
Yes, LinkedIn is fine. Also via mail, via ChatGPT, it's all fine.
Very good. Daniele Gamba, D-A-N-I-E-L-E, Daniele Gamba, G-A-M-B-A, or AISent as the company name, AISENT. We'll put both of them in the podcast notes as well. Otherwise, dear listeners, if you have any questions or comments, as always, please send a short email to me, to peter@aipod.de. I'm happy you stayed with us so far. Looking forward to have you with us again next time. Daniele, thank you very, very much.
Thank you, Peter. Thank you very much. It was a pleasure to be here.
Thank you. Have a nice day. Bye-bye. Ciao.
Bye-bye. Bye-bye.